Welcome dear learners. We are continuing Unit 5 Inorganic Chemistry Practicals 1 Volumetric Analysis. In this module we are discussing experiment number 3 Estimation of Mohr salt. The contents of this module are mention about permanganometry, aim of the experiment, principle behind the experiment, reagents required for the experiment, procedure of the experiment, that is preparation of standard oxalic acid solution, standardization of potassium permanganate and estimation of Mohr salt. Finally, we have results of this experiment. First of all, permanganometry. You are very much familiar with the volumetric analysis, that is a titration or that is an analytical method involving measurement of the volume. It is important in quantitative analysis. The titrations involving potassium permanganate belongs to the category of permanganometry, and this is the clear-cut definition of permanganometry. Permanganometry is a redox titration method that uses potassium permanganate as a titrant or as an oxidizing agent. KMnO4 acts as a strong oxidizing agent in acid medium. In permanganometry titrations, we have to standardize the KMnO4 titrant first. For this purpose, we are using a standard solution of oxalic acid or Mohr salt. Generally, acid medium, in order to create acid medium, dilute sulfuric acid is preferred. During the reaction of KMnO4, manganese plus 7% in KMnO4 is reduced to manganese plus 2. In sulfuric acid medium, KMnO4 is converted to MnSO4, that is manganese sulfate. KMnO4 is self-indicating and end point is generally the appearance of a pale pink color. It should be noted that in permanganometry titrations, you need not use any external or internal indicator because KMnO4 is a self-indicator. Aim of the present experiment. Aim of the experiment is here. Estimation of mass of Mohr salt in the whole of the given solution. You are provided with approximately n by 10 solution of potassium permanganate and analar oxalic acid crystals. We are entering into the principle of the present experiment, that is potassium permanganate solution is standardized with a standard solution of oxalic acid based on this reaction. The reaction between potassium permanganate and oxalic acid in acidic medium is shown here. 2 KMnO4 plus 3 H2SO4 plus 5 molecules of oxalic acid produces K2SO4 plus 2 MnSO4 plus 8 water plus 10 molecules of carbon dioxide. Standard KMnO4 is titrated now against given Mohr salt solution, and that is based on this reaction. 2 FeSO4 NH4 twice SO4 6H2O, that is Mohr salt, plus H2SO4 plus nascent oxygen which is liberated during the previous reaction gives Fe2SO4 thrice plus 2 NH4 twice SO4, that is ammonium sulfate, plus 3 molecules of water. So, the principle of this reaction involves standardization of potassium permanganate first using a standard solution of oxalic acid. Using that standardized solution of KMnO4, you can estimate Mohr salt given in the Mohr salt given. Now, equivalent mass of KMnO4 in acidic medium is 31.6. This is because molar mass divided by 5. Because this reaction just shown here is a 5 electron process. So, change in oxidation number is equal to 5. Molar mass divided by change in oxidation number will give the equivalent weight of oxidizing agent or reducing agent. This concept is familiar to you. Based on that, the equivalent weight of KMnO4 in acidic medium is calculated as 31.6. Now, equivalent mass of oxalic acid dihydrate. Oxalic acid dihydrate has a molecular formula of H2C2O4, 2H2O, which is having a molar mass of 126. It is a dibasic acid and hence its equivalent mass will be equal to molar mass divided by 2, that is equal to 63. Equivalent mass of Mohr salt is same as its molar mass, that is equal to 392. Mohr salt is ferrous sulfate, ammonia sulfate, 6H2O. Now, reagents required for the present experiment. These are the reagents required. Number 1, AR oxalic acid crystals. Number 2, approximately n/10 solution, KMnO4 solution. Number 3, Mohr salt solution for estimation. And number 4, dilute sulfuric acid. We are now entering into experimental procedure. First of all, the experiment consists of the following steps. The first step is the preparation of a standard oxalic acid solution. This is the second step, that is standardization of KMnO4 by titration between KMnO4 against oxalic acid. And last stage is the estimation of Mohr salt. Here we are performing the titration between potassium permanganate and given Mohr salt solution. First of all, preparation of standard oxalic acid solution. Mass of H2C2O4 to H2O required to prepare 100 ml of n/10 solution can be calculated by using the expression weight required is equal to VEN divided by 1000, where V represents the volume, E represents equivalent weight, and N represents normality. Here the volume is equal to 100 ml, equivalent mass equal to 63, and the concentration of the solution is 0.1 normal. So the weight required can be calculated as a 0.63 gram. Now, roughly weigh out to 0.63 gram of oxalic acid and transferred it to a dry weighing bottle. It is then weighed in an electronic balance accurately, and the weight is reported as W1. The substance is now transferred to 100 ml standard flask through a funnel and make up to the mark. The weight of the empty weighing bottle is now taken as W2. The actual weight of oxalic acid will be equal to W1 minus W2, that is the difference in weight. This weight W1 minus W2 is used to find out the concentration of the oxalic acid solution as normality equal to weight per liter divided by equivalent weight. Now, the second part of the experimental procedure, that is standardization of KMnO4. Here we are performing the titration between potassium permanganate and oxalic acid. Set 2 burettes, we are performing titration by double burette method. For this, set 2 burettes, one burette with KMnO4 and the other burette is filled with oxalic acid solution. 16 ml of oxalic acid is added to the conical flask and mixed with the 10 ml to normal sulfuric acid, since you are performing the reaction in acidic medium. Now the solution is heated to nearly 70 degrees Celsius. Remember, this heating is very important for the smooth completion of the reaction. It is then titrated against a KMnO4 and end point is determined. Remember, the end point is the appearance of a pale pink color. Here you need not add any external or internal indicator because KMnO4 as such act as a self-indicator. Now, from the tighter values, we can calculate the normality of KMnO4 using the relation N oxalic acid into V oxalic acid is equal to N KMnO4 into V KMnO4. To this solution left in the conical flask, add 2 more ml of oxalic acid and heated. It is then again titrated against KMnO4 and determine the end point and calculate normality. Now, the process is repeated for 20 ml, 22 ml and 24 ml of oxalic acid, and normality is calculated in each step by using the previous relation. Average of all these values is taken as the normality of unknown solution. Graphical method can also be used to determine the unknown concentration. Now, standardization of KMnO4 demonstration. We are now demonstrating the standardization of calculation. The weight of oxalic acid taken is equal to W1 minus W2 and let it be equal to 0.6352 gram. Weight of oxalic acid per liter is equal to 0.6352 multiplied with the 10 and that will be equal to 6.352. Then normality of the oxalic acid solution that you prepared equal to weight per liter divided by equivalent weight, that is equal to 6.352 divided by 63, which is equal to 0.1008 normal. Now the titer values in standardization can be tabulated as follows. These are the titer values. These are the volume of oxalic acid taken. Corresponding titer values of the KMnO4 are here. You can also calculate normality by using the expression, and normality is calculated using the expression N KMnO4 is equal to N oxalic acid into V oxalic acid divided by V KMnO4. N oxalic acid is calculated previously, which is equal to 0.1008 normal. Substitute all these values and you have to get the normality in each case, which is tabulated and shown here. Now, the normality of KMnO4 solution is the average of all these values. You can calculate average by adding these 5 values and divided by 5, and N KMnO4 you will get it as 0.0996 normal. Now we are entering into last part of the experiment, that is nothing but estimation of Mohr salt. Here we are performing the titration between KMnO4 and Mohr salt. The given Mohr salt solution is made up to 100 ml by adding 10 ml dilute sulfuric acid solution while making up. This addition is to prevent the hydrolysis. Set up 2 burettes, one with the KMnO4 and other with the Mohr salt. 16 ml of Mohr salt is added to the conical flask and mixed with 10 ml to normal sulfuric acid solution. Here no heating is required. It is then titrated against a KMnO4 at the end, and the end point is determined. From the titer values, we can calculate normality of the given Mohr salt solution using the relation N Mohr salt into V Mohr salt is equal to N KMnO4 into V KMnO4. To this solution left in the conical flask, add 2 more ml of Mohr salt. It is again titrated against a KMnO4 and determine the end point and calculate normality. Now the process is repeated for 20, 22 and 24 ml of the Mohr salt and the normality is again calculated in each step. Average of all these values is taken as the normality of the unknown solution. Graphical method can also be used to determine the unknown concentration. Now estimation of calculation of the estimation part. The titer values can be tabulated as this. First column represents the serial number of the titration. Second column denotes volume of Mohr salt that you taken in ml. Next column represents volume of K-manophore, which are the titer values, and the last column represents the normality of Mohr salt, which is calculated. And these are the tabulation. The normality of Mohr salt is calculated using the expression N Mohr salt is equal to N K-manophore into V K-manophore divided by V Mohr salt, or N K-manophore is already calculated by the standardization procedure as N K-manophore equal to 0.0996 normal. You can substitute these values. By using these titer values, it is possible to calculate normality of the Mohr salt solution in the 5 cases. So, the normality of the given Mohr salt solution is the average of all these 5 values, and you can take average like this. N Mohr salt will be equal to 0.1012 normal. The weight per liter of the given Mohr salt is equal to normality multiplied with equivalent weight, that is 0.1012 multiplied with equivalent weight of Mohr salt, that is equal to 392. You will get the weight per liter is equal to 39.67 gram per liter. Mass of Mohr salt in the whole of the given solution can be calculated by using this equation, weight per liter of Mohr salt divided by ton. This is because you made up the given solution into 100 ml. So, weight of the substance in the whole of the given solution is obtained by dividing weight per liter by ton, and the value will be equal to 3.967 gram. So, this about the reporting of the final results. The normality of the given Mohr salt is equal to 0.1012 normal. The weight per liter of the given Mohr salt solution is 39.67 gram per liter, and finally mass of Mohr salt in the whole of the given solution will be equal to 3.967 gram. That all about the present experiment. Have a nice learning experience. Thank you.